All right, welcome back to another lesson for Math 8. This is actually the most important lesson from all the final lessons. We are going to talk about sine, cosine, and tangent today, lesson 118. So I don't have a lot of time to waste, so let's get into it. All right, so in a previous lesson, I think it was 112, according to the book, we talked about finding different types of ratios based on and focused on an angle, right? So it had to do with an angle. So if you looked at the angle, you would know what it is. If you guys don't know what I'm talking about, you definitely have to go back to look at lesson 112, because if not, you're going to get pretty lost in this one. So always in reference to an angle. So it had to be with right triangles, right? So we're going to talk about this exclusively for right triangles again. Okay, this is the beginning of trigonometry for reals. And so we have three things: sine, cosine, and tangent, right? This is one of the reasons I wrote this over here. SOHCAHTOA. I know it looks pretty weird, but it's very helpful. It is extremely helpful, and I hope that everybody remembers it. SOHCAHTOA is not that hard. I know it sounds kind of weird, but that's literally the way I learned it in high school. And to be honest with you, this is one of the ways that I can remember it, if I forget it. But I've been doing it for so long that, I mean, I can't forget it. It's dumb if I forget it. Anyway, we're going to talk about these ratios based on an angle. So based on angle A, and I'm going to explain several things that the book doesn't, which I think they kind of skim over a lot of important facts, which are super important. So we have sine A, cosine A, and tangent A. So what this means is this. First of all, let's do sine, cosine, and tangent without A being the point of reference, but just in general. So sine, what does sine mean? Sine means the opposite side of the angle we're talking about. Opposite side over the hypotenuse. All right, the opposite side over the hypotenuse. Cosine means the adjacent side over the hypotenuse. I already went what the opposite side was in that video. I also know that everybody should know what hypotenuse is. And then the tangent then is the opposite over the adjacent. So that is pretty easy, right? But then how do you actually remember what goes where? This is where SOHCAHTOA comes in. And SOHCAHTOA is actually divided this way. SOHCAHTOA. So, it means sine is opposite over hypotenuse. What does ka mean? Ka is cosine, is adjacent, over hypotenuse. And then what does toa mean? Toa, it's tangent, is opposite, over adjacent. Oh, terrible D. Beautiful line there for this one. Oh my goodness. So bad. Better. So that's what it means. SOHCAHTOA means sine equals opposite over hypotenuse. Cosine, it's adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Very important, very easy to understand. So, having said that, then what are the ratios here? Well, because what we talked about were ratios. Sine is a ratio, cosine is a ratio, tangent is a ratio. A ratio of what? A ratio of sides from the point of view of an angle. What is the angle? The angle's A. What is the opposite of A? Opposite of A is side A. So we're going to have A over hypotenuse, which is C. What about cosine? Cosine is the adjacent. The adjacent is B over C. And the tangent of A would be A opposite over adjacent over B. That's it. So that's the sine, cosine, and tangent according to angle A. But wait, the one thing that your book doesn't tell you is by the way, this is the shorthand. This is sine, cosine, and tangent, as you can see in your calculator. Obviously, yours doesn't look like mine, but maybe next year it will. So this is a TI-84 Plus, but it's a calculator anyway. And I'm going to show you real quick here so that you understand what I'm talking about. Come on, there you go. We have sine, we have cosine, and we have tangent. That's what I'm talking about. So let's go back to the board. And we have then sine B, cosine B, tangent B, right? So sine, cosine, and tangent of B. B being this angle. What is the opposite? The opposite is B. And sine is opposite over hypotenuse. Opposite over hypotenuse. So opposite over hypotenuse is, and I'm actually going to write it down so that you kind of get into the habit of knowing what it is. Opposite is B over C. Cosine is adjacent over hypotenuse. Okay, cosine over hypotenuse. The adjacent is A, side A, over C. And then the tangent is the opposite over the adjacent. The opposite sign being B, adjacent being A. B over A. So what am I trying to show you? What I'm trying to show you is this. Look at this. AC and AC. So the sine of A is the same thing as a cosine of B. BC and BC. Whoa, wait a second. The cosine of A is the same thing as sine of B. And tangent, well, we have B over A and A over B. The tangents then are reciprocals of each other. These are things that you should know because different triangles will have relationships like this. All triangles, by the way, that are right triangles will have a type of relationship like this. So if this side angle, for example, was 30 degrees, then this one would be 60 because 30 plus 60 is 90, and this is a right triangle. So that's how you do it. So it's cosine A would be the same thing as the sine B. The sine of A would be the same thing as the cosine of B, and tangent of A would be the reciprocal of tangent of B. Okay, so that's what I wanted to show you. Let's actually get into the examples. All right. All right, in example 1, we have triangle, right? And it says find the sine, cosine, and tangent of angle A. So I put SOHCAHTOA TOA here so that we remind ourselves, because I erased it from the top, what it means. So sine of A would be the same thing as opposite over hypotenuse. So sine, opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse. TOA means tangent is opposite over adjacent. Obviously, we're talking about sides, right? So A, what is the sine of A? The sine of A is the opposite over the hypotenuse. Sine would be opposite, which is 6 over 10. 6 over 10 is the same thing as 0.6. Cosine. The cosine is the same thing as adjacent over hypotenuse. The adjacent is 8, the hypotenuse is 10. 0.8, right? tangent. The tangent would be the opposite over the adjacent, right? So the opposite is 6. The adjacent is 8. The same thing as 3/4 or 0.75. And that's how you find the sine, cosine, and tangent of this particular angle A in this triangle. All right, let's move on to the other example. All right, in example number 2, we have another right triangle, and this time it's RST. And so we're supposed to find the sine, cosine, and tangent of 30 degrees. So very important, you write it like this. Sine 30 degrees, cosine 30 degrees, tangent 30 degrees. That's how you find it. That's how you write it, I mean, not find it. That's how you write it. However, how do you find it? Well, the important thing here is to know that this is 60 degrees then, and you have to remember your ratios. Remember back to special triangles, we actually had a lesson about special right triangles in which we actually used a 45, 45, 90 and the 30, 60, 90. You have to know those ratios, okay? The ratios are as follows. The ratios are 1, square root of 3, 2. How do I know that? I just remembered it, or not remember, but I just memorize it, right? So 30 degrees, the opposite side is 1. For 60 degrees, the opposite side is square root of 3. And for 90 degrees, the opposite is 2. How did we get to this? We actually used the Pythagorean Theorem to be able to do it. So we actually did it that way. So now that we did that, we actually are able to find the sine of cosine, of sine, cosine, and tangent. And so very important. This one is going to be opposite over hypotenuse. This one is going to be adjacent over hypotenuse. And this one's going to be opposite over adjacent. Sine of 30 degrees. The opposite side is 1. The hypotenuse is 2, I mean. So it'd be 0.5. 1/2, 0.5. The adjacent is square root of 3 over 2. That one is a little bit harder to do it with decimal numbers, but the book does it. Note, I'd rather you don't, because you can't use a calculator. And if you give me an exact answer, obviously I will know that you've been using a calculator. And then the opposite would be 1 over square root of 3. So this is about, by the way, these can only be estimations for the last two. It's 0.866. It's about 0.866 according to your book. And this one is 0.577. The only one that you can actually do is the first one. But you're getting the idea of it. This is where all the stuff that we've actually been teaching you before kind of comes together. This is why this lesson is not supposed to be super hard, except for the names themselves, sine, cosine, and tangent. But everything else we kind of have been doing before in other lessons. So if you have not been paying attention, that's where you get hurt. And I wish that everybody watched this video, because it's there that people are not going to know what happens then. And this is going to be so important for math later on. Okay, in the third example, you're supposed to use a calculator. I'm not going to use a calculator. I hope that you know how to use a calculator. It's not very hard. It's just pressing buttons. The only thing that I'm going to do now is I'm going to talk about what is actually after example 3, which is so dumb because they don't even put it in any example, and yet you're supposed to know how to do it. This is where we actually start getting very tricky with sine, cosine, and tangent, and you need to know what we're talking about. So let's actually talk about that instead of example 3. Example 3, you can just get a calculator and do it, follow along. But let's actually do what's after example 3. Okay, let's do that. All right, so this is actually where the practical uses of this type of information starts to get here. So we have a diagram, right? Or a little diagram. So from this distance to the tree, there's 100 feet, right? And a person, let's say it's looking up to the top of the tree, and they know it's 22 degrees. How do they know? I don't really know how they know this, but it's just an example of how to do it. Okay, so you have an angle, you have a side, but you don't know the hypotenuse, and you don't know this side over here, which is going to be opposite of 22 degrees. So this is where we have to pay attention to what we learned. We learned 3 new ratios, right? We learned sine, cosine, and tangent. Sine and cosine, they both use the hypotenuse. Do we know the hypotenuse? No. Are we going to use the hypotenuse? No, because we don't have the measurement for the hypotenuse. So we don't know well, we could get it, but that makes no sense for us. That's not what the point is. The point is that we're going to use this side, which is what? 222 degrees. It's adjacent. This side, 100 feet, is adjacent to 22 degrees. Okay, so that helps us a little bit. But now we have to find the height of the tree. How do we find the height of the tree, though? Well, we have to find one of the ratios. We need one of the ratios. Well, the only other ratio that doesn't use hypotenuse would be tangent. Maybe we should use tangent, okay? Because it would use the opposite over the adjacent. Opposite over adjacent is TOA, tangent. So tangent of 22 degrees would be the same thing as the opposite over the adjacent. Right? So far, so good. The opposite we don't know. The opposite is the height of the tree. So let's say tree height. The adjacent we do know. It's 100 feet. Okay. So where does this take us? I mean, we have tangent of 22 degrees equals, let's call this x, by the way. X over 100. How do we do that? Well, this is where we actually do need to use a calculator. And that's what the book doesn't tell you. This is why I don't think that this is such a good idea, because it's kind of dumb. Anyway, how do you do it? Well, I'm going to show you really quickly in the calculator here. So let me just zoom in for a little bit to the calculator. So this is a calculator. It's different than yours, obviously, but all you need to know how to do is press tangent. So it will show tangent, and then press 22. Tangent of 22. And then you press enter. Enter. Look at that. We got 0.4040. We're actually just going to use 0.404. That's what your book used, I think. Yep. So, let me put you back in the board. Boom. Whole view of the board. So, in here we get tangent of 22 degrees equals 0.404 equals x over 100. This is also going to be 1, right? So now we can actually do a cross product or cross multiplication. 1 times x and 100 times 0.404. This is going to be pretty easy because it's going to be 1 times x is x, and 100 times 0.404, we're going to move the decimal 2 places, and it's going to become 40.4. The tree is 40.4 feet tall. That's how you would be able to do it. So hopefully you understand how to do it, but again, you do need to have a calculator. Not this one, just any calculator really that can do. It's called the scientific calculator, what you guys get. You need a scientific calculator. This is called a graphing calculator, which is what you're going to be using next year. So that's it. This is it for the hardest lesson that we had left. Lesson 119 and 120, you will see that are not as hard as you think they would be. So that's it for today. 2 more lessons to go. Who's excited? I'm excited because I can't stop making these videos. Yay!